Hello everyone, I am Snigdha Kakkad and this is my channel AccelerateAICareers. Today I have brought a very interesting hard level LeetCode problem, LeetCode 84, largest rectangle in histogram. Now this question has been asked by several FAANG companies and other companies in their last 0 to 6 months of interviews. Some of them being Amazon, Google, Meta, Microsoft, Myntra, DoorDash, Bloomberg, Apple. So this question is really an important one just because of the algorithm and intuition behind this question. So let's see what does this question say. You have been given an array of integers heights as shown in example 1 here, and it represents the histogram's bar height, where the width of each histogram bar is 1, as you can see in example 1 image also. And you have to return the largest area or the area of the largest rectangle in the histogram possible. For example, in this histogram several rectangles are possible, such as an histogram with width of 2 and height of 5. So if you see, height of 5 is possible with only these two histograms and width would be 2 here. So rectangle here would be 5 into 2, which is 10, as shown in the image here. There could be other rectangles possible as well, such as a rectangle with width of 6 and height of 1, and area in that case would be 6 into 1, 6. So similarly, you will compute areas of several rectangles possible and then return the largest area possible in this particular example or any example for that being. Now I would suggest you pause this video here and try solving the question yourselves. A hint for solving it is that you can use some additional memory, some data structure that uses additional memory such as a stack, and try solving this question. If you have any doubts, play the video, understand the intuition I'm going to use to solve this question, and then try solving it yourself. Still any doubts? Mention in the comments, I'll be happy to address it. So let's start understanding how you can solve this question. Now to explain the intuition I'm going to use to solve this question and code it further, I have taken 6 examples here on the right side you can see. And each example I'm going to guide you how I'm going to see which rectangle starts with which index and which rectangle ends at what index, and now what would be the max area. So like in example 1, you have a decreasing order heights. So like your first histogram bar has height of 2, second histogram bar has height of 1. So what would be the rectangles possible and what would be the area possible? So if you see, as soon as you decrease the height from 2 to 1, the height of 2 for a rectangle becomes impossible then. You can have a rectangle of height 2 only until 0th index when your next height is not less than that. So that's why if you want to have height of rectangle as 2, then the area would be 2 into width. Width would be start index 0 and end index 1, because as soon as the index turned 1, the height reduced to 1. So if you see as an example 1 also here, you have starting in height as 2 and then the height reduced as 1. So you cannot have a rectangle possible of height 2 and width 2 here because there is a drop in height in the next index. So maximum width possible for a rectangle with height 2 would be 1 here. So as soon as you move to the next index where reduced height is there, you have to pop the prior higher height histogram bar and rectangle as well. So the max area for rectangle with height 2 would be 2 multiplied by 1 and 2. And then you will pop this rectangle with height 2. And then you will have this rectangle with height 1. But if you see, that height 1 doesn't start at index 1. You can back extend it. And that height 1 rectangle is still possible from the prior histogram because its height was greater than 1, not less than 1. So your height 1 rectangle is possible for width of 2 rather than width of 1. So that area would be width 2 into height 1, and again max area would be 2. So the intuition behind decreasing height histogram is, as soon as the height decreases, you have to first pop the higher order height and get the max area from that. And then if the height has reduced, you can back extend and increase the width of the current height. That is the lower height rectangle, because it can take height from prior histograms also which were taller than it. Now, even if it is not clear now, let's look at another example. So say suppose you have increasing order heights. So 1, 2, 3, 4 like that. Okay. In that example, I can explain it to you from here. Like you have first bar as 2 and then as 3, right? Similar to that, as soon as the height increases, you don't need to pop anything. You can just add the next height 3 with starting index as this, whatever the starting index for 3 is. So like one height started at 0th index, and that goes on till the last, till the next histogram also, because its height is greater than the first one. So you can have one height and extend it to the next one. So your width would be 2 and your height would be 1 here for this example 2. So 1 into 2, your A max area for height 1 would be 2. But let's check for max area for height 2. As soon as the height increased to 2, you cannot back extend it because the prior histogram was of lower length. So its width would be from its starting index itself to the end of the histogram. So its width would be 1 and its height would be 2. Again, max area would be 2. I hope you understand that and it's becoming clear how I'm working on it. As soon as a higher order height is there, you keep on adding it to your whatever data structure you're using. In my case, I'll be using a stack. And as soon as a height reduces, then you have to pop the top of the stack value, the higher order height, because you cannot extend that height rectangle further. As the height has reduced, it has taken a drop. So you have to pop that first, calculate the max area. And then the lower height which you have added now, you can add it. But its starting index would not be the value which you are adding it. Its starting index can be back extended because that rectangle of lower height can extend even to the prior values. Now, next example is that your histogram is of equalized length. That is, all heights are equal to 2, 2. In that scenario, you don't need to pop anything and you will have a 2-height histogram continuously from starting index 0 to the end of the histogram bar. So basically your height would be 2 and your width would be 3 and your area would be 6 here. I hope that's clear. Now, in example 4, you have 1, 2, 3, 4 increasing heights and then 3, a height drop. So until 1, 2, 3, 4, you will keep on adding to the stack because you can extend that histogram until then. As soon as the height dropped, before adding the next histogram of 3 height, you know that height 4 histogram cannot be extended any further since the height dropped. So you have to first pop the top of the stack value, that is 4, and you calculate the max area. So the max area for height 4 would be width. Width would be 1 since there is no other histogram with height 4. So width would be 1, height would be 4. So you will first compute that, update your max area, and then you will pop that value. Once you pop that value out, your histogram would look somewhat like this, and you will add this 3 there. But you will not add this 3 value starting with index 5 there because there was a 4 here, right? So you will not add it with starting index 5 there because you can back extend this 3. You can back extend this 3 with starting index as this 3 value. So it can start with rectangle of height 3 from this place itself. So the index is 2 here, so it will be added with index 2 here. And you can pop this 4 out. So the max area, if you check for rectangle of height 3, and width would be 1, 2, 3, the area would be 5. So this max area would be replaced with this max area and this would be your max area. I hope you understand the intuition behind the question. Let's try one more example. So here it's again increasing histogram bars 1, 2, 3, 4, but then suddenly the height drops not to 3 but to 2. The intuition behind it still remains the same. As soon as the higher order height decreases to a lower order height, you have to pop the top of stack value. So you pop this 4 first because now you cannot continue with the rectangle of area 4. But now you notice that even the height 3 is greater than height 2. So you cannot even continue a height 3 rectangle. So you have to pop that also. Then you had height 2 rectangle. But the starting index for that height 2 rectangle will not be index 5 where you are adding it, but it would be this index 1 because from there onwards you can have a rectangle with height 2. So starting index would be this 1 index and it goes on till the end of the histogram, which was 5 index. So the width would be 5 minus 1, 4. And your height would be 2, which is 8. Max area. Now similarly, if you have increasing order heights and then suddenly the height drops from 4 to 1, in that scenario also, the same intuition will go on. You will have to pop this 4 out because you cannot continue with a 4 height rectangle. Same, you will have to pop this 3 out, and you will also have to pop this 2 out, and then add that 1. And the starting index of this one rectangle would be 0. So the width would be 5 and the height would be 1. So I hope you understand the intuition. We'll be using stack data structure. And now the time complexity and memory complexity. Since I'm going through the entire array of heights once, and I'm pushing those values to stack and popping those values from stack only once, the time complexity would be O of n. And same way, since I'm using additional data structure stack here, the space complexity would also be O of n. If you have a better time complexity or memory complexity solution which is more efficient, share it in the comments. I'll be happy to learn from you. Now let's start coding this question. Now first of all, I will initialize my max area variable because that's the one thing which I have to return as a result. And I'm also going to return max area because that's what I'm going to return in the very end. In between, I'm going to initialize my stack, and my stack would have two things. It would have a pair of index and height. So every time I'm not just going to update that this height is going to start, I'm also going to update that this is the starting index for the rectangle with this height. Because when I'm adding, say, height 1 rectangle, it need not start with index 1 here. It will start with index 0 here because you can back extend it to a higher height bar prior, and it can still have height 1 rectangle there, right? So that's why I will always be storing pair of index and height and not just heights. Now I will enumerate for I, h in enumerate heights array, and I will also initialize my start because my start could be different, but I will initialize it with I for the time being. And I'll update the start accordingly if the next height coming is lower than the top of the stack value. So for that, while the stack has some values and the top of the stack value in the stack, top of the stack value would be -1, stack -1, and its first value, that is, would be height, 0th value would be index. So stack -1 will give you a pair which is on top of stack, and from that the first index value would be your height, and you check if that is greater than your current height which you have come across. If that is the case, your higher order height which was on top of the stack, that rectangle cannot continue any further and you have to pop it out. That was the intuition, right? So you pop it, but you will be popping out a pair out of the stack. So index comma height is equal to stack dot pop. This max area would be max of whatever your current max area was, comma, whatever height you have popped, that height, because you have to compute the max area which would be possible with the value you are just popping from the stack. So the value you have popped is this height in the prior row, and you take that height, and what would be the width? The width would be your I index which you are adding right now, enumerate. So that I index minus the index you have popped, that was the starting index of your higher height value. So that gives you the width. And then you take the max of current max area and then this area, height into the current width, I minus index, and you update your max area. Also, in that case, when you are adding a lower height value and your prior height was greater than this height, the top of stack value showed you that. In that case, you can back extend this lower height rectangle as I told earlier. So to back extend, you will set this start index to this index where you popped. Because until that index, your lower height rectangle can continue if you back extend. So that's what I did. And then you append the new value, height index pair, that is the lower height value pair, to the stack. So start would be the index and h would be the height. And that's how you keep on updating the stack. But don't forget, when you have gone through the entire stack, popped any such values which were on top of stack, which were of higher height than the height now being added, after that you have gone through the entire stack and there are still certain values remaining in the stack. So for those pairs, you also have to compute the area and update the max area accordingly. So for I, h in stack, max area would be max of current max area value, whatever the current max area is, and then whatever stack has the height, that height multiplied by what would be the width of the rectangle, since these values are still in the stack when you have gone through the entire stack, that means they have the rectangle width which goes on till the end of the heights array. So length of heights, that is this entire heights array, length of heights minus whatever the starting index of that rectangle height is, which would be this I. This will give you the width. So you can update your max area accordingly and then return the max area. So whatever your max area would be will get updated and then you can return. Let's run this. Your solution is accepted. Let's submit. As you can see, our solution is doing quite well here. Now you will still have certain doubts. Why did you update your max area with width, this I minus index here? Why did you update your max area with width of length of heights minus I here? I know you have certain of those doubts. So let me take an example 1 here, and walk you through using the same code which I have done for you here. So I have taken this example 1 here as shown here in the picture also. I've taken these heights array, and now I will initialize my stack, which will have two things, index and height pairs as soon as I add these values from the heights array. And I will also keep on updating my max area here. Now, first height which you have is 2, which will get added at index 0. So let's add that. Now, next height which you have, this value I added to my stack, the pair, index comma height pair. As I told you, I will be adding these pairs and not just the height. Now, next value which I have is 1, and it starts at index 1. But this value 1 is less than the top of stack value. The top of stack value is 2. So you cannot extend a rectangle with height 2 any further. So you have to pop that up first, pop that out from stack first before adding that 1. So to pop it out, I'll first remove this 2. And as soon as I pop it out, I have to calculate the max area with rectangle of height 2 first. Height is 2 and the rectangle's width with height 2 would be 1. As you can see, as soon as you go to the next value, the height reduces. So the width would be 1, which would give you max area is 2 here. So I'll just update the max area to 2. And now you can add the next value. The next value of height is 1. But the starting index would not be 1 here. The starting index would be 0. Because you can back extend it as the higher order height was there before. And you can have a rectangle of height 1, which is lower height, in the prior bar as well. So that's why I had updated max area as max of max area and height, which would be 1 here, multiplied by I would be a current index, which is 1, minus whatever the index was which you popped. So the index you popped was 0 with height 2. So 1 minus 0, that would be your new width. So I would basically add 0, 1 here rather than adding 1 index for it. Now let's come to the next height. Next height is 5, which is greater than 1. So you don't need to pop the prior values, and you can just add 5, which will be starting at index 2, and the value of height is 5. Next value is 6, which will get added at index 3, and height would be 6. Since the height 6 is greater than 5, you don't need to pop any of the stack values. Now your next height which you come across is 2, which is less than this 6. So you have to first update your max area and pop this pairs 3, 6. So your max area which will get updated now will be of height 6 rectangle. So height 6 rectangle is possible starting with index 3 only, as the prior height was 5, which was less than that. And this height 6 rectangle cannot also go beyond this index. As soon as you go beyond this index 3, you have a lower height which is 2. So you cannot have a rectangle of height 6. So this height 6 value, as you pop, the width would be just 1. This is how I computed from this image, right? But if you compute using formula, your height would be 6 and your width would be the current index which you are dealing with is 4, right? This index which you're dealing with is 4. And the height you popped is, the index you popped is 3. So 4 minus 3, 1. So this is the formula I used again, okay? And your max area gets updated to 6. Now you can pop this value up. But you cannot add the next value right now, as the height 2 is still less than height 5. So you have to pop this value also. But you first have to update the area. So to update the area, you will have height 5 multiplied by width. The current index you are dealing with is 4, and the height 5 has index starting as 2. So 4 minus 2, 2, and your max area would be 10. So you can update the max area first, again using the same formula, and then you can pop this out. Once you have popped it out, you can add the height 2, which was starting at index 4, but you cannot add index 4 here because this height 2 is less than the prior two heights 6 and 5, so that can be back extended. The rectangle 2 can be started not from just index 4, it can be started from index 2 itself. And that's why we update the start index here in our code, and we append the start index as 2 and the height as 2 as well. I hope you understand the code better now. Now next stack value which you can add is of height 3, which is greater than the current height on top of stack 2. So you don't need to pop it up, you can just add. And the index value which you will add is 5, 3. And now you have come to the end of the stack. But your stack is not empty. There are certain values in the stack. So you have to update your max area if possible. So how you update that max area is in this row 15. So you go through all the values index height pair in stack and then update the max area. Since all these rectangles with these particular height are possible till the end of the heights array, so you can use this width. Length of heights would be 6 and height would be 1. So 1 into 6, 6, which is less than this max area, so you cannot update it, but you calculated it. Now in next index height pair is 2, 2. So your width would be length of heights, which is 6 minus 2, 4. And your height would be 2. 4 into 2 is 8, which is again less than this max area, so no need to update it. Now next value is this. You'll have actually one width here and height would be 3. So the max area would be 3 again, which is less than 10. So hence your max area is 10 and you can return it. So basically, we have to update the max area going through all the remaining values in the stack and then computing max area for each of them. If either of them yield a max area greater than your current max area, you update it. If they don't give you a value greater than your max area, you keep it as is and return the max area. I hope the code is clear to you now. If you have any further doubts, ask them in the comments. I'll be happy to address it. If you like my way of solving problems, subscribe to my channel to get your notifications for your daily LeetCode challenge. Is there any specific question you want me to prioritize and solve? Also do mention in the comments. Let me know how you find my solution solving skills here, and I'll be happy to take in your feedback in any manner whatsoever. Thank you again for watching this video. Subscribe, like and share.